Sage was founded in 2019 with the support of NSF. And now, we're driving the next transformation in AI at the edge, where intelligent sensors become alive. The goal is to create a novel cyber infrastructure to exploit dramatic improvements in AI technology and to build a continent-spanning network of smart sensors. To address challenges of data volume, Sage will embed computers directly into the sensor networks and rely on advancements in edge computing to analyze the torrent of sensor data as it streams past, enabling scientists, citizens, and devices to automate and empower decision-making like never before. Argonne is pioneering Sage to make environment data more accessible, autonomous, and consumable in creating a more sustainable future. The reusable cyber infrastructure running on these Sage testbeds will give climate, traffic, and ecosystem scientists new data for building models to study coupled systems. Sage is accelerating digital by providing a software-defined sensor network critical for understanding the impacts of wildfires, global urbanization, and climate change. Emphasizing open source, Sage provides an open architecture platform to enable scientists to build their own intelligent sensor networks, opening the door to citizens, students, and interns to write code that can measure a near limitless number of urban and environmental elements.
Hello everyone, my name is Yufeng Luo, and I am a second-year PhD student studying astronomy at the University of Wyoming. And this summer, I am a WJ Cody associate at the Sage Group. My work involves doing machine learning tasks to learn images from a coaxial camera. The coaxial camera has two cameras. One of them is an RGB camera, just like the camera on your phone. And another one is a thermal camera, which basically taking the pixel as a thermal Celsius degree. And my task this time is basically learning from what RGB camera can mapping from IR, what's the information the actual pairs would have. So this is a preliminary result I can show you. You see the RGB and IR, they are all pairs. RGB sky and IR skies, for example, like this cluster, they are the same cluster. You can see the model we use here is a vision transformer. It's like the ChatGPT, but it's also focused rather than on natural language processing. It's actually focused on images. So those, you can see VIT did a really good job to really separate different clusters apart. You can see there's clear boundaries. I didn't really remove any noise, so any noisy data are here. You see that they are in the same, even though they are in the same cluster, they actually are a different part of the cluster, which means the model learns different part of information from the pairs.
Hi, I'm Jacob Shumney. I'm a junior at the University of Illinois Urbana-Champaign studying information and data science. I am mostly interested in machine learning, which is why I became an intern here at Argonne for machine learning. My current project focuses on detecting smoke in camera images in order to reduce forest fires and the negative effects that come with them. What I've done in my project is create a data set and also train a model on that data set in order to try to help the cause of preventing forest fires in the future.
I'm Chase Pelletier, and I'm currently attending Michigan Tech. I'm studying electrical engineering, and here at Argonne, my project involves using software-defined radio, along with these Sage nodes, to record the electromagnetic signals that come off of lightning strikes. So whenever lightning strikes, it puts off big waves of energy, and I can detect those with my SDRs, and it will record that data whenever it occurs and send it right to me to be used for any other kind of science.
Hi everyone, my name is Ananga and I'm a current sophomore at the University of Illinois at Urbana-Champaign. And for my Sage project, I worked with rideshare vehicle detection in the city of Chicago. So I used a YOLO V8 image identification framework to detect rideshare decals or stickers on top of windshields for cars. And the resulting image predictions as well as the count of the rideshare vehicles detected were published to the website for users to use. Now there's a lot of use cases for this, including citizen safety, transportation planning and development, infrastructure development, city planning and zoning, and also alleviates any problems of city officials having an inadequate rideshare data set to make data-driven informed decisions about public transportation in their cities.
Hi everybody, my name is Joseph Cannon. I am a rising senior at Northwestern College in Naperville, Illinois, studying electrical engineering. Right now at Argonne, during this internship, I've been working on making APIs for all these cameras that you see around us, this one in particular, and then also an API for this switch as well. The reason that I'm doing this is to be able to give the rest of the people on the Waggle team and Sage team access to be able to use these cameras for their machine learning algorithms or to track clouds, cars, face detection, and just to keep track of things. So just to allow them to be able to interact with the hardware. And then later on this internship, I will be installing these nodes all throughout O'Hare area.
Hi, I'm Alex, and I am a rising senior at Northwestern University, and I'm studying computer science and cognitive science. This summer, I'm working on creating a machine learning model to classify whether there's snow on the ground or not, and hopefully also to do a snow segmentation model. This is mostly being done at the Bad River, which is a site in northern Wisconsin from the Waggle node there, and it can be to solve a variety of problems, such as using these images of snow to predict things like wild rice agriculture in the area, or things like turbidity about the river, and hopefully this will be part of a greater data set that may be used by other scientists for looking at snow and the climate in general.
Hi guys, my name's Alex and I go to Northwestern University. I'm a rising sophomore. And I'm studying computer science. In my internship at Argonne, I'm developing a machine learning model that basically takes images of the sky and then it goes through the model, and then the model is supposed to spit back a solar radiance level, which is basically like the overall energy that the sun's outputting towards the earth. And I think this could be useful to Argonne because if solar energy is a really big thing right now, renewable energy, and just using solar radiance levels to just predict future solar radiance and use it for solar panels.
Hello everyone, my name is Anaka Tiwari and we're here at Argonne National Lab in the village of Lamont in Pete's beautiful office. It's a nice sunny day outside. You can see the forest in the background. And we have some amazing experts here with us, here to answer some questions about SAGE. So SAGE is a novel national cyberinfrastructure for AI at the edge. And we're going to hear some interesting perspectives today. So why don't we get started with this fun panel, and let's get started with introduction. So you can explain your role with SAGE and more about yourself.
Thank you very much. So I'm Pete Beckman, and I work at Northwestern University and Argonne National Laboratory, and I am excited and enjoy this project. I'm the lead for the SAGE project from the National Science Foundation because it brings students and new science together.
Hi, I'm Mike Pepka. I'm at Argonne National Lab in the University of Illinois, Chicago. I have a number of different roles within the SAGE project, working with Valerie on education and outreach, as well as helping kind of deploy the infrastructure around the city of Chicago.
I'm Raj Sankaran. I'm with Argonne National Laboratory and Northwestern University. I'm actually the platform architect for SAGE, so I build those things which go on street poles and mountains and wherever, and try to survive the summer and winter.
Hi, I'm Valerie Taylor. I'm at Argonne National Lab and also Northwestern University. And I'm happy to be a part of SAGE, in particular the education and outreach component of SAGE, and it's really great to engage the students.
Hey, I'm Sean Chakrami. I'm also at Argonne and Northwestern. I've been working on some of the edge computing stuff with projects like Waggle and Sage for about 7 years, and recently lead the software team.
All right, sounds good. Thank you so much for your introduction. I'm super excited that you all are here. Why don't we get started with the questions? So, Pete, what is the vision for Sage?
Yeah, so Valerie and Mike and I and others have worked most of our career in supercomputing. We just have worked in massive parallel supercomputers at universities, at the laboratory, and the vision for Sage was that there is a way to take that kind of power that happens in a supercomputer and sort of shrink it down and put it out into on top of mountains or in the city. And so the vision was, could we write and build an infrastructure where artificial intelligence lives out in the devices and automatically looks at data and processes it. And so this was a new infrastructure. No one has ever built this kind of infrastructure before. So the exciting thing about Sage was it was an invention. It was a new piece of infrastructure that allows people to write code like for the supercomputer, but write code that goes all the way out and lives in the woods or in the city or somewhere else.
That sounds great. Thanks so much for sharing. And Mike, what are the Sage use cases for digital progression, smart cities?
Well, this is a great question. I think the answer is there's infinite use cases.
Yeah.
So that's very hard to pin down, but I think some of the great things about Sage is just being able to take this data in the city that you normally wouldn't get, or you'd get in a very small sampling, and being able to get it on a much larger, wider perspective.
That's very nice to hear. So Raj, you said you worked with a lot of the hardware for Sage.
Yep.
What are some of the deployment opportunities for the Sage Waggle nodes that get installed?
Wonderful. What drives deployment as a science, right? So if there is something interesting that we want to do, whether to understand the environment, whether to basically interact with the environment, that's what drives the real deployment. So we have situations where people want to understand traffic flow in cities, flooding in cities. People want to understand, air pollution, how it changes with vertical height and horizontal spread.
Yeah.
So generally speaking, anything that requires both short-term and long-term understanding, and anything that requires understanding which does not come directly from specific sensors, but needs some kind of action on the data by using edge computing is something that we focus on. So opportunities everywhere, I'd say.
No, that sounds great. Thank you so much for sharing that. And Valerie, every summer you have interns that are working on these edge apps or plugins. How are they, so valuable to the mission?
So interns are valuable to Sage from two aspects. First is their insights that they bring to the project. And that is, we have students coming from many universities across the U.S., and so they're bringing their background to bear with respect to the projects that they're working on. And then second, having the interns involved with Sage is also important in terms of workforce toward the future. And that is, when we look at having Sage deployed, in cities and rural environments, you also need a workforce that's helping in terms of evolving Sage. And so the engagement with the students is looking at it in terms of a long-term aspect, because now you have students who are familiar with Sage that can carry on the vision of Sage. So it's many different aspects that students can help in terms of their background, in terms of future, but also exciting the students.
No, that's pretty great to hear how students can have these opportunities that are so unique and work with such amazing people so closely. So that's pretty cool. And Sean, I guess our last question: what are some of the future areas of evolution for Sage?
Sure. So this is a good question. One of the important parts of Sage is kind of the open aspect of it and being able to get people in, develop their own stuff. But one thing that I think we could do a little better here is Sage doesn't exist in a bubble. There's a lot of other communities, especially in the AI space, So for example, something like Hugging Face, it's a really big community. There's a very active group working on stuff there. And I think if one of the things we focus on, not really as a specific technical feature, but a direction, is integrating better with those communities, sort of leveraging all the people doing work there. That'll actually feed back a lot into our own work so that we can take advantage of all these different models, data sets people are building, and really sort of get better engagement with what's now like a really quickly growing group of people in this space.
No, that sounds pretty amazing. How SAGE not only involves, the side of the scientists, but also, as Sean mentioned, all those communities that are, working towards building new models. So thank you so much for sharing all your thoughts. These were some very interesting perspectives from a lot of different backgrounds, and I really enjoyed being here. So thank you so much.
Thank you. Thank you.
I enjoyed the interview. So thank you.
And don't trip all the way out there.
I know, you have to remind me.
All right.
Cutting edge.
Cooperative.
Open source and democratic.
Innovative.
Interconnected.
Open size distributed network.
Accessible.
Scientific playground.
Data powered.
Community. Disruptive.
Sustainable.
New ideas.
Curiosity driven.
Touching the sky.